Hello, PreCalc. Here is the date. So we're watching this after Tuesday's class, and it is more PreCalc review, and we are going to be asked to find the difference quotient. So the difference quotient has to be known, and it is f of x plus h minus f of x divided by h. And we're going to apply that to this function. So this function says when you put x into it, or you put anything into this function, it multiplies it by 3 and then it adds 4. So this is asking us to put x plus h into this function. So it's going to multiply what we put in by 3 and add 4. So we just took care of that. Now the minus sign took care of that. F of x is stated 3x plus 4. Notice it follows the minus sign and will be affected by it, divided by h. So the rest is simplifying. 3x, and this is where it gets really fun because so many things will drop out. 3x's and the 4's. And we end up with 3h over h. So the only thing that remains is a 3. And that is the difference quotient for this function. Alright. The second one, we've got to get through 13 instead of 12 problems. So let's see how we do. Alright. This function, I'm going to ask you to graph it without a calculator. So we have the square root of 1/2 x, so that's under the square root, plus 2, outside of the square root. So in order to do this one, we have to start with the parent, which is something like that. And we have to remember that this 1/2 is inside the function, so it causes a horizontal change. And when it's less than 1, between 0 and 1, it is a horizontal stretch. So I'm going to take this and we're going to stretch it horizontally. So we're going to pull it like this. What will that do to the graph? It'll flatten it out even more than it is. And then we raise up this flattened guy up 2. So we end up with a flattened function, stretched function, raised up 2. Alright, the third one, I'm going to give you the function and ask you for its graph. So this is a step function, and it goes like this. Alright, so you need to get all of this down so you can do your work tomorrow, so pause if I'm going too fast. So you recognize the parent, I think, is the greatest integer function, and I've noticed that we have to make a change to it because normally it started here, and this started here, and this started here. So this has all been moved over to the right one. So that causes, inside of our step function, a -1. Alright, so that is the name of this function that is pictured. Alright, number 4, another one to graph. G of x equals 1/2 x plus 2 quantity cubed. So on this one we start with the parent, which is the cubic, and we're going to do headstrong, rebellious, and violent. Horizontals come first, so this is 2 to the left. And should parallel the picture a little better than that. So it'll look just like this, but 2 to the left. Alright, is there a stretch? This time there is. And that 1/2 means, since it's outside of the function, it's going to be a vertical shrink. So I'm going to take this and I'm going to shrink it in the vertical direction. So that will cause this to flatten out. So the way we flatten it is like this. And finally, I guess that's it. That's all we did. We took care of this and we took care of that. Alright, so there's our flattened function. Alright, number 5, graphing again. This one is a blast from the past. We know that this is hugging the x, so that's whatever this function is, it's going to be left 2, but we have to recall the parent. It's not a true parent function, but it's one we've had before, and that is when we have a to the x. And when we have that function, it is going to be a graph that always crosses this point. It has a tail on this side, and we should do one other point. So I'm thinking of y equals 3 to the x. So when x is 0, y is 1. That's where this one comes from. When x is 1, y is 3. So it goes zinging up on this side, and it tails off on this side. Alright, but that whole graph has to be moved over to the left too. So I usually take this cross point and move it over, and so I end up with this as my final one right here. Alright, number 6. Let's work with logs probably most of the rest of the night, going a little deeper into logarithms. So this is an expression that we need to understand, and I want you to write it in exponential form. Exponential form has no word log in it and only exponents, so it's always this number raised to this number is this number. Should create a true statement, which it does. Alright, let's go the other way. I'll give you one that is in exponential form, and I want you to write it in the logarithmic form. So we're going to put the word log in it, like number 6 started. So notice this is the base number, so we're going to log to the base 4 of this is that, because a log is an exponent, so we should have an exponent sitting over here. Alright, number 8. Without a calculator, no calculator, calculate y equals log to the base 2 of 1 over 32. So this is a log is an exponent, and it is the exponent that we give 2 to get 1 over 32. And you'll notice that 2 raised to the minus 5 is 1 over 32. So that is your answer, minus 5. Remember, negative exponents will flip the number, and that'll become 1/2, and the 2 on the bottom will be raised to the 5. 2 to the 5 is 32. Alright, let's graph a log equation. Alright, so a log equation is graphed. Here's the basic log equation. Well, we'll do 2 points, 2 sissy charted points. We'll do, I'm just going to do log to the 4 log to the base 4 of x. And then we'll just move it again to this time it'll go to the right 2. So log to the base 4 of x is what we'll start with, and it is always going to use this point and then this point. So what exponent do I give 4 to get 1? 0. And this point is on these basic ones. And what exponent do I give 4 to get 4? 1. So I go over 4 and up 1. So you'll recall the basic log graph looks like that. And now we have to move it to the right 2. So it'll come over here like that. Alright. Number 10 is one that we called expand. So we're going to start with one logarithm, that's to the base b, of the 5th root of x to the 4th y over z cubed. So rules of logarithms will help us do that. So remember, we can rewrite x, this whole expression, x to the 4th y over z cubed, raised to the what? Instead of this box, the 5th root box, we can use the fraction 1/5. So now we are going to break up this. One of the rules of logarithms allows us to move that exponent down in front where it becomes a coefficient. And now we'll apply the other rules of logarithms. And we found that when two logs are multiplied, we can write them, when in the argument two values are multiplied, we can write it as two logs that are added. So, and when two logs are divided in the argument, when quantities within the argument of a log are divided, we can write it as two logs subtracted. This 1/5 will affect all of that, so we'll just keep it outside. So watch this. Log to the base b of x to the 4th plus log to the base b of y. Because these were multiplied, I can change them to two logs that are added. And the last one comes out as a subtraction. Okay, we're not done yet because all of these exponents can run down in front. Well, this one just doesn't have one, but these do. So 4 runs down, and you know what? Let me see. See if I wrote this correctly. And I did. Alright, so now all I have to do is have these values run down in front. So this can be 4 log to the base b of x plus, that one doesn't change, log to the base b of y. This one, the 3 runs down in front, log to the base b of z. And now this 1/5 can be distributed through for the best answer. 4/5 log to the base b of x plus 1/5 log to the base b of y minus 3/5 log to the base b of z. Alright, so all that started with one log. We ended expanding it to 3 logs, no exponents left. Alright, so that's called expansion. Let's look at one on number 11 where the values are already expanded. And we want to go ahead and condense them. So the command is condense on number 11. -4 log to the base b of x minus 3 log to the base b of y plus 1/5 log to the base b